Hello, my name's Bob Smith, and this tutorial is about setting up and running CLUZ and Marxan. So it will begin with a bit of background on systematic conservation planning, then I'll explain how to use the files used in CLUZ, the software that I'm demonstrating today. I'll show you how to set up CLUZ, how to explore the files, and then how to use CLUZ to run Marxan. All of the files that I'll be using today are available for free. So the tutorial files you can find on the CLUZ website, which is there, as well as the CLUZ tutorials and guide. To get hold of Marxan, you need to go to the Marxan website shown there. And also I'd recommend signing up for the CLUZ mailing list, as that's the best way to find out when new versions of CLUZ are available and when new tutorials are up as well. And there are links to all of these in the text below this video. So to start with a very brief background about what systematic conservation planning is. Well, it's an operational model for identifying and implementing the management of priority conservation areas, and it's designed to be efficient, repeatable, transparent and equitable. There are a couple of key publications on this. The first is the original Nature paper by Margiles and Pressey from 2000, and if you've got a bit of money and a bit more time, I would highly recommend reading the Conservation Planning book by Groves and Game, which covers all sorts of issues that are really important for understanding this process. But a key part of systematic conservation planning is the process of identifying where your important areas for conservation are, and that's known as the spatial conservation prioritization. So what does the spatial conservation prioritization involve? Well, it can be seen as a several-step process. The first is that you identify the planning region, the area that you're going to work in. Second, you identify your important conservation features. So these are the species, habitat types, ecological processes, ecosystem services, anything that you want to be conserved and represented in your priority areas. Next, you divide your region into planning units. So these can be hexagons, squares. If you're on land, it could be watersheds, properties, anything that will be the fundamental unit that you're going to select in the analysis. Next, you measure the amount of each feature in each planning unit. Next, you set the status of each planning unit. You identify the ones that are already conserved, already protected, and should be included in all your outputs. But you also identify the ones that should be excluded, that aren't suitable for conservation. Then you produced a cost value for each planning unit, which will be the cost of including it in your network of priority areas. That cost could represent just the area of the planning unit, or in this case, it could be the opportunity cost of fishing. On land, it could be the cost of buying the land or managing it. There's a whole different set of metrics that you can use. And then finally, you set targets for each conservation feature. How much of each of the species and habitat you want to be represented in your final network of conservation areas. So once you've got your data ready, you can now do your spatial conservation prioritization. And this normally involves using different software packages to identify the sets of planning units that meet the targets whilst minimizing planning unit costs and maintaining connectivity. And there's a whole set of different software packages available for this. And what I'm going to tell you about today is CLUZ, which is designed as a user-friendly interface for Marxan, which is the most widely used spatial prioritization software. Okay, so we're now ready to look at the files that are used in CLUZ and Marxan. So to illustrate those, I've already downloaded Marxan onto my C drive, and you can see the different Marxan files there. And I've also created a folder called CLUZ Data, and in it I'm going to unzip the tutorial data. So now you can see I've got a folder called CLUZ EX1 that contains the data that we need to use. So next I'm going to display the planning unit shapefile, and I'll do that by going into QGIS and clicking on adding a layer. So here is the planning unit file that we're going to use in this tutorial. You can see it consists of a whole series of hexagons, but also it's been clipped to the planning region, and you might also be able to see down this line that some of the planning units have been divided into smaller sections. And so that's to represent the protected area, which I'll show you about later. And if I open the attribute table, you can see that this shapefile has got a set of fields. The unit ID, area, cost and status always have to be there. Those are the core fields for using CLUZ, and the unit ID gives a unique ID value for each one of those planning units. The area gives its area, which in this case is 25 for most of these hexagonal planning units, to represent 25 hectares. In this case, we've set the cost to be the same as the area, so they also have 25, and also we have the planning unit status, which I'll talk a bit more about later. So as I said, most of these planning units are simple hexagons, but we also wanted to represent the protected area boundaries as accurately as possible. And in that case, we've actually unioned them with the protected area boundary. So I can click on this planning unit here, and you can see that its edge marked there means that it's on the edge of the protected area. And again, that will become clearer later on. There are two other files that I want to show you that are in the tutorial folder. The first of which is the targets.csv file. So that's used by CLUZ, and what it does is it lists all the conservation features that we're interested in and that we have data for in the planning region. So again, each one of those conservation features has its unique ID, and then this file also gives its name, the target, which is the amount of each feature that we want to conserve, and then a set of other data that I'll explain about later. And then to show you the Marxan files that come with the tutorial, well, the first one is the puvspr2.dat file, which is a simple text file which lists the amount of each feature in each planning unit. So as I explained before, each species or conservation feature has its unique ID, each planning unit has its unique ID. So you can see from this top layer that conservation feature with an ID of 30, in planning unit 1 there's 6.938, in this case hectares, of that feature in that planning unit. So this is how Marxan knows where all the different conservation features are found. And the other folder here is the sporder.dat file, which is identical to the puvspr2.dat, but in this case it's ordered based on the conservation feature ID, the species ID. You can see this is listed as with all the ones first, whereas with the other file it's ordered based on the planning unit ID. So to come back to QGIS, we're now ready to install CLUZ. I've shown you the files that come in the tutorial. The first thing I'm going to do is remove the planning units from QGIS, and now I'm going to install the CLUZ plugin. So I'm going to go to the CLUZ plugins menu, click on manage and install plugins, look for all and search for CLUZ. And there's CLUZ 3 there. So I'm going to click on install plugin. Now I can close because that's worked, and you can see that we now have a menu called CLUZ in the main menu bar at the top with a whole set of functions there, and also there's a set of buttons that come with CLUZ. So the first thing I'm going to do is set up the tutorial files. So I'm going to go to view and edit CLUZ setup file, and I get this list here because at the moment nothing's been installed. So this is just a simple dialog box that lets me specify where all the files that I want to use in this tutorial are found. So I'm going to start by clicking on the browse button for the Marxan location. I'm going to go to the folder where I've installed Marxan, and I'm going to choose Marxan x64 because this is a 64-bit computer. Now I'm going to specify where the CLUZ data is kept, and for the input folder, so this is the input folder where all of the Marxan files are kept, which here we've called input, and then the output directory, the output folder, is the one where all the Marxan files will be saved, and again that's currently a blank folder called output. Then I'm going to specify the planning units, that shapefile that I showed earlier, and the target table. So similarly, that target table that I showed earlier, that CSV file that contains all the information about the targets. So I've now specified all the pathways. I'm going to say that I want the data to be recorded with 3 decimal places because that's how it's currently stored. And I'm going to click on Save As to save this folder to the CLUZ tutorial 1 folder, and I'm going to call this EX1 because it's exercise 1. And click on Save, and if I close this, you can see that this has worked and in doing so, CLUZ has automatically loaded the planning unit shapefile, and that's displayed here. But you can see now it's coloured based on the status of the planning units. So you remember earlier when I showed you the shapefile that there's a field called status, and this is reflected here. So in CLUZ there are 4 types of status. There's available, which is this light green that shows these are planning units that are available for selection. There's also conserved planning units, so that's the dark green. These are the existing protected areas, existing conservation areas. Then there are planning units that are excluded. So these are ones that Marxan will never select. And the 4th category is earmarked. At the moment we don't have any earmarked planning units. These are the ones that are earmarked for conservation. So they're not conserved yet, but they do help meet the targets. So one of the buttons that's been added to the toolbar, the target button, and if I click on that, this now shows that original CSV file that was in the tutorial folder, but now it's displayed more nicely, and it shows us again the ID of each conservation feature, its name, its type, and that's just used to group the different conservation features into different categories, the target, which is the amount that we want to protect, the amount that we want to conserve, the SPF, which stands for species penalty factor, which I won't go into at the moment, ear plus cons. This tells me the amount of each feature that's in earmarked and conserved planning unit. Total tells me the amount of the feature in the whole planning region, and then PC target is the percentage of the target that's met. So you can see that for this montane aquatic, at the moment, none of it is in any type of conservation area, so the percentage target met is 0. Whereas if we look at the acacia thicket, conservation feature number 9, because a lot of that habitat, nearly 3,000 hectares of that habitat, is in the protected areas, and that's more than the target of 2,020 hectares, we've met the target. And that's why this is showing we've got more than 100% of the target met, so that number is in green, whereas everything in red shows the target hasn't been met. So to just briefly show some of the extra tools in CLUZ that you can use to understand your data and also do on-screen spatial prioritization, I'm going to illustrate for montane aquatic, which as you can see at the moment is currently not conserved at all, and go up into the menu and say show display the distribution of conservation features, and I'm going to show you where the montane aquatic is. And you can see from here, here's the map of the montane aquatic, and you can see that it's a whole set of streams and rivers in this montane area, so it's fairly fragmented. But what I can do in CLUZ is select an area here, so I'm going to digitize some of the planning units. I'm going to bring up the change status panel, and I'm going to set them as earmarked for conservation. And now when I go back and open the target table, you can see that by adding that patch of planning units, earmarking them for conservation, I've now met that target for montane aquatic. So I've chosen an area with lots of montane aquatic in it, and now I've met the target. So this just illustrates the sort of thing that you can do in CLUZ for doing on-screen spatial prioritization. Doing it this way is fairly inefficient and clunky, but it illustrates the sorts of things that you can do and shows the links between changing the status of the planning unit and how that helps you meet the targets. So now that I've done this, I'm going to close the target table. I'm also going to remove the montane aquatic layer to make things easier to see. And I'm going to go back to the beginning. I'm going to start with a blank slate. And to do that, I'm going to click on the button that says change all the planning units that currently have the status of earmarked to available. Okay, and now I'm ready to run Marxan. So to run Marxan, I first need to produce the Marxan files. So one of them is already created, the PUV SBR2.dat file that I showed earlier, but there's a set of other files that we need to make too. So to do that, I go to the Create Marxan Input File option, and I'm going to click on that I want to make the target file, planning unit file, and the boundary file. And I click on OK. So if I go back to the input file now, for the tutorial, you can see that 3 extra files have been created. One of them is the spec.dat file. So that's very similar to the target CSV file I showed you earlier. It's just that CLUZ uses that CSV file, whereas this is the file in the Marxan format, which gives the ID, name, target, SPF value and type for each of the features. pu.dat is another text file, this time turning the planning unit shapefile into the data that Marxan needs. So again, we have the planning unit ID file, which gives the unique planning unit ID for every planning unit. We have the cost, we have its status as to whether it's conserved, excluded or available, and we also have the X and Y location. So this gives you the coordinates of the center of each planning unit, which Marxan doesn't use, but it's actually used by other parts of CLUZ. And then we also have the bound.dat file. So this, for every planning unit, shows the amount of edge it shares with its neighbor. So we have ID1, ID2 and boundary. So for that first row shows that planning unit 1 and planning unit 4 share 5.49 meters of edge. That's the amount of boundary that they share between them. So now we can go back to CLUZ, go to the CLUZ menu and say that we want to launch Marxan. So there's a whole set of parameters here that I won't explain. There's a lot more detail in the Marxan tutorials, but in brief, using Marxan involves running it a certain number of times, with each run consisting of a number of iterations. So the longer the number of iterations, the better the results that you get from Marxan. So here I'm going to use the CLUZ default of each run is going to be of 1,000,000 iterations. We're going to do 10 runs, and CLUZ is giving the automatic output file name of output file 1. And I'm going to just do a very, very basic analysis, and I'm going to click on Start Marxan. So that launches Marxan there. This is Marxan with the black box that's very quickly gone through those 10 different runs. You can see it's finished. I'm going to press enter, and CLUZ has automatically loaded the results. So there are two types of output here. The first one is the best output. So as I said, Marxan has run 10 times. It then identifies the best of those 10. And by best, it means the one with the lowest cost. So the one that's met the targets with the lowest cost. The other output is the selection frequency output, which counts for every planning unit the number of times it appeared in one of those 10 outputs. So you can see that a few of these planning units, the ones in deep red, have been chosen in each one of the 10 times. Then lots of others have been chosen a bit less than that. You can see the ones in the very pale yellow have only been chosen a few times. The ones in orange have been chosen 6, 7, 8 times out of the 10. And then there's a set in grey that weren't selected at all. So in terms of checking how well the best output met the targets, I can click on this button here, which changes the status of the best units. So the ones in magenta that were identified by Marxan, and I'm now going to incorporate them into the CLUZ results and make them earmarked. So if I do that, I can turn off the best output and show that here in CLUZ we've now got a portfolio of planning units that have been earmarked based on the Marxan results. And if I click on the open target table, you can now see that all of the targets have been met. So by selecting those planning units, Marxan has met all the targets. So that was a very simple analysis that was just interested in choosing the individual planning units and didn't care about how fragmented the results are. As you can see from this result, the planning units identified by Marxan are very scattered. So I'm now going to rerun the analysis, and this time I'm going to set it so that Marxan chooses less fragmented results, that it chooses bigger patches of planning units. So to do that, I'm first going to remove the previous Marxan results, and I'm going to click on the button to wipe the slate clean, to say change the status of the earmarked units to available. By doing that, if I just show you the target table again, we've gone back to the original situation where not all the targets have been met. And now I'm going to run Marxan again. So I'm going to go launch Marxan, Again, stick with the same parameters, but this time I'm going to include a boundary cost. So I'm going to set what's called the boundary length modifier to be 0.5. So this now gives a cost to having lots of edge. And when we run Marxan, Marxan will reduce that cost by choosing bigger patches. So again, I'm going to run Marxan. And again, because it's a relatively simple set of analyses, it will do it quickly. I'm going to close Marxan and show the two results. So here is the best output, again from running Marxan 10 times, and you can see that the results are very different. It's chosen much bigger patches. Planning unit, there are still a few isolated ones, but in general there are these big patches, and Marxan has also preferentially selected planning units next to the existing protected area. And in terms of the selection frequency, you can see that again, because of this focus on reducing fragmentation, the areas that have been repeatedly selected have tended to be in bigger patches. Again, to incorporate those results into Marxan, I'm going to click on the button that says change the status of the best units to earmarked. So here's the results shown in CLUZ. And again, when you open the target table, you can see that by identifying those planning units and making them earmarked, we've met all the targets. So that's an overview of CLUZ and Marxan. I've given you a very brief introduction to systematic conservation planning. I've shown you the files that you need for CLUZ and Marxan, and I've shown you how to run Marxan through CLUZ and adjust the boundary length modifier to give you different types of output. So I'll finish by encouraging you to sign up to the CLUZ mailing list, and please get in touch if you have any questions.